All right, problem number 2. This is a calculated problem once again. A particle moves along the x-axis with velocity given by v of t equals 10 sine of 0.4 t squared all over t squared minus t plus 3 for the time from 0 to 3.5. The particle is at position x equals -5 at time t equals 0. So for part A, it asks to find the acceleration of the particle at time t equals 3. So keyword here is going to be that we're looking for the acceleration, and we know that the acceleration is the derivative of the velocity. So we actually, to get the acceleration, of 3, we would like to find the derivative of the velocity at 3. And since the velocity is given, we simply can just do math 8 using the velocity, and we'll be finding it at t equals 3. And when we plug that in, we should get -2.118. And this problem was just worth 1 point. If you got the right answer, you got your point. All right, part B, find the position of the particle at time t equals 3. So if I'm looking for a position, there are two things that I need to consider. Where is the particle at right now? And then what is the displacement? So those are the two things. So initially, you'll notice at time t equals 0, the particle is at -5. So this particle is at -5. And now we need to decide, remember, displacement is just how far the particle has moved. So to get displacement, we are going to take the integral of velocity. Okay, we just need to figure out from where to where. So if this started at 0, we're going to start at 0, and we need to figure out how far has it moved from 0 to 3. So that is the setup that I'm going to be using. We can put a dt here. I don't think we'll get marked off if we don't put that. When we type this in our calculator, we'll get -5 plus. I'll use math 9 to help me out in this one. I will get 3.240, and when I add those two together, I'm going to get -1.760. So this would be the position of the particle at time t equals 3. Okay, I'm going to get 3 points for this problem. I'm going to get 1 point for my integral setup. I'm going to get 1 point for considering where the particle was to start with, and then I'm going to get 1 point for my right answer. Part C, we're going to evaluate the integral from 0 to 3.5 of v of t, and then we're going to calculate 0 to 3.5 of the absolute value of v of t, and then we're going to interpret the meaning of each integral in the context of the problem. So there are actually a few things that I need to do. I'm going to find this, I'll find this, and then I need to interpret the meaning. Okay, so this right here is simply just typing it in our calculator. We can do math 9 to do that. So if I type that in my calculator for math 9, I am going to get 2.844. So I could say the integral from 0 to 3.5 of v of t is equal to that. My next thing, same thing, we're just going to go to find the absolute value when I do that. And when you type that in your calculator, you can just go to math number and you'll find the absolute value symbols. And when you do that, you're going to get 3.737. And then it says to interpret the meaning. Well, we just found out this from part B, I believe. This will just give us the displacement. So this represents the displacement, I know I spelled that totally wrong, displacement of the object on the time interval. I want to make sure that I include what the time interval was, 0 to 3.5, or I could say from time equals 0 to time 3.5. So however you want to word that, that's fine. Okay, when we add in the absolute values, we know that that's going to represent the distance traveled. So this represents the distance traveled by the particle. This time I'll put from t equals 0 to t equals 3.5. So either one of those ways would be fine of saying it. So we would get 1 point for getting the 2.844. We're going to get 1 point for calculating the 3.737. And then we are going to get 1 point for both of the explanations. So one including both of those. All right, part D. Second particle moves along the x-axis with position given by x of 2, sub 2 of t equals t squared minus t, still the same time interval. At what time t are the two particles moving with the same velocity? So we want to find out, where does the velocity of particle 1 equal the velocity of particle 2? Okay, so we already know the velocity of particle 1, and I'm actually going to call this v1, v sub 1 of t. So we will let the reader know that I'm going to be referring to that as v sub 1 of t. So I would like to find out, what does v sub 1 of t equal v sub 2 of t? So I'm going to rewrite this. We're going to have 10 sine, and actually I wouldn't really need to rewrite this because I might end up rewriting it incorrectly and then get a point off or something like that. Okay, and then the velocity of particle 2, well, if we know the position of particle 2, we know the velocity is just the derivative. So the derivative of t squared minus t is going to be 2t minus 1. All right, and then I would just like to find, where do those two equal each other? So I'm going to be putting this in my calculator as y1, which is probably already in there as. I'm going to put this one in as y2, and then I'm going to be looking for their point of intersection to find out where are they equal to each other. And I will be changing my window. I would want my x min to be 0, and I want my x max to be 3.5. And I do remember I did have to zoom on this one just to make sure there was only one point of intersection, and it looked something like, I had a picture that looked something like this, and then another one that looked something like that. So I'm looking for this point of intersection right there, and that point of intersection happened to be t equals 1.571. So that would be the time the two particles are moving with the same velocity. I would get 1 point for setting the two equal to each other. And then I'd get 1 point for actually getting the right answer. So either this step or this step would be appropriate to get my points for that part of the problem. And that is problem number 2.